Assalamualaikum warahmatullahi wabarakatuh. For Physics 534 video presentation, our topic is about optical fiber in oil and gas industry.
Optical fiber is a technology that uses light signal to transmit data through thin glass or plastic fibers. It provides high-speed communication, low signal loss, and high reliability compared to traditional electrical cables. In the oil and gas industry, optical fiber is widely used for communication, monitoring, and sensing in environments such as pipeline, offshore platform, and deep wells. It helps improve safety, operational efficiency, and real-time monitoring, making it an important technology for modern oil and gas operation.
Okay, for this part, let us see what is principle of optical fiber. In physics, it means it operates on the scientific principle of TIR. So, what is TIR? TIR is total internal reflection. Now, let us see how light travels in core versus cladding. Light travels strictly through the core, kept inside because the surrounding cladding layer has a lower refractive index. And now, let us see what is repeated reflection. Repeated reflection is light bounces repeatedly within the core without escaping, which allows data to travel over an immense distances with minimal signal loss. That's the definition of principle of optical fiber.
Hello everyone, moving on to the technical composition of our topic, let's take a look at the physical makeup of an optical fiber. It is fascinating how such a thin string can carry so much data across vast distances. Generally, fiber optics are constructed from silica, which is a highly purified glass or plastic. The choice of material depends on the application, but for high-stake industry like oil and gas, ultra-pure glass is the standard. As we can see in this diagram, the cable consists 5 distinct layers, each serving a critical purpose. First, the core. At the very center is the core. This is the heart of the fiber made of ultra-pure glass or plastic. This is the actual pathway where light passes, which carry our data travel. So, second one is the cladding. Surrounding the core is the cladding. This layer is vital because it has a lower refractive index than the core. This difference causes a phenomenon called total internal reflection, essentially acting as a mirror that reflects light back into the core so no signal is lost. Next, we have the coating, often called the buffer. This is a plastic layer that provides a necessary cushion for the fragile core and cladding. It also acts as the first line of defense against moisture. Because these cables are often pulled through long pipeline, they need mechanical strength. We use strengthening fiber. Typically, it made of material like Kevlar to absorb tension and prevent the glass from snapping during installation. And last for this fiber optic is outer jacket. Outer jacket is the tough exterior shell. It protects the entire internal structure from environmental hazards such as harsh weather, chemical, and physical impacts. Now, why do we use this specific material for the oil and gas industry? The theory behind optical fiber sensors allow them to perform tasks that traditional sensors simply cannot handle. In the context of oil and gas, these sensors are deployed to monitor hydrocarbon pipeline over very long distances. Let's break down the theoretical advantages of this technology. So, one of the most critical applications is the ability to detect oil and gas leak at a very early stage. By identifying a leak immediately, operator can prevent catastrophic fire and environmental accident before they escalate. Oil and gas wells are among the most difficult environment on Earth. Fiber optic sensors are uniquely qualified for this because they can withstand high temperature and extreme pressure that would destroy standard equipment. For data integrity, because the system uses light signal for transmission, the data is fast and highly accurate. Perhaps the biggest theoretical advantage is that fiber optic overcome the limitation of conventional electrical sensor. Electrical sensor can be prone to electromagnetic interference and more dangerous. They can create spark, which is a massive risk in a volatile oil and gas environment. Since optical fiber use light, they are inherently safer. By combining this robust material with advanced sensing theory, we create a monitoring system that is safe, durable, and incredibly efficient for the industry. So that's all from my part. Thank you.
Now, I will explain the application of optical fiber technology in the oil and gas industry. The first application is distribute temperature sensing, or DTS. In this system, optical fiber are used to monitor temperature continuously along pipelines and oil wells. This help engineers detect leaks, overheating equipment, abnormal heat change, and the fire risk at the early stage. As a result, company can improve safety and reduce maintenance costs. The second application is distribute acoustic sensing, also known as DAS. Optical fiber can detect sound wave and vibration along pipelines and drilling areas. This technology is used for leak detection, pipeline security monitoring, and monitoring drilling activities. It allows operators to identify problems quickly and respond faster during emergencies. Another important application is downhole monitoring. Optical fiber sensors are installed deep inside oil wells to measure pressure, temperature, and flow rate in real time. The information collected helps engineers improve oil extraction efficiency and reduce operational risk. Besides monitoring, optical fibers are also used in communication system. In offshore platform and refineries, optical fiber provide high-speed data transmission with low signal loss. They are also resistant to electromagnetic interference, making communication more reliable between control rooms and field equipment. Last but not least, optical fiber technology is used for structural health monitoring. Fiber optic sensors monitor the condition of pipeline, offshore platform, and storage tank. They can detect crack, corrosion, strain, and vibration before serious damage occurs. This helps prevent accidents, reduce repair costs, and improve overall safety in the oil and gas industry.
Now, let us see what are the advantages of optical fiber in oil and gas industry. So, for the first advantage is high-speed data transmission, where optical fibers can transmit large amount of data at very high speeds, and this can help the operational operate efficiently. So, for the second advantage is real-time monitoring, where optical fiber sensors continuously monitor important parameters such as temperature, pressure, vibration, and pipeline condition, where this will help all the doctor can monitor patient carefully and details. And the third advantage of optical fiber is it is resistant to electromagnetic interference, which is EMI. Unlike electric cables, optical fibers are not affected by EMI or heavy machinery or power system, where this can make sure all the data were correct and reliable.
Although optical fiber technology provides many advantages in the oil and gas industry, there are also several challenges and limitations. The first challenge is the high installation cost. Fiber optic system requires specialized equipment, advanced monitoring system, and skilled technician. Because of this, the initial setup cost is more expensive compared to conventional sensors and communication system. The second challenge is the fragility of optical fibers. Optical fibers are thin and delicate, so they can be easily damaged by excessive bending, mechanical stress, or harsh drilling operation. If the fiber is damaged, data transmission may be interrupted. Another limitation is difficult maintenance. In offshore, platform or deep underground wells, repairing damaged optical fiber is complicated, time-consuming, and costly. Sometimes operation need to be stopped during the repair process. In addition, the oil and gas industry operates in extreme environment with high temperature, high pressure, and corrosive chemical. This harsh condition can affect the performance and lifespan of optical fiber sensors. Lastly, fiber optic systems generate a large amount of data. Advanced software and trained experts are needed to analyze and interpret data accurately, which can increase operational complexity. Therefore, despite its many benefits, optical fibers technology still faces several technical and economic challenges in the oil and gas industry. Optical fiber technology has become an important part of the oil and gas industry due to its ability to provide accurate monitoring, high-speed communication, and improved safety. Applications such as temperature sensing, acoustic monitoring, downhole sensing, and structural monitoring help companies increase operational efficiency and reduce risk. However, the technology also faces several challenges, including high installation costs, difficult maintenance, and harsh environment conditions. Despite this limitation, continuous advancement in fiber optic technology are making the system more reliable and cost-effective. Overall, optical fiber technology plays a major role in modernizing the oil and gas industry and will continue to support safer and more efficient industrial operational in the future. Thank you.